Our next topic is on the concept of percent yield. Now, percent yield, in order to do this, you have to have an understanding of stoichiometry, and I'm also going to incorporate limiting reactants. So percent yield, again, it will involve a chemical equation. So let's say let's going to go back to what I've been using all along in my other videos, where we have acetylene gas reacting with oxygen to produce our carbon dioxide and our water vapor. Now, when we talk about percent yield, we can pick a mass. Let's say, not pick a mass, but let's say a mass is given to you that it's 50.0 grams of acetylene, and let's just say 180 grams of oxygen are going to react with it. But when we talk about percent yield, that means the amount of product that's actually produced. So let's say you're also given in this problem that the percent yield for this particular reaction, and I'm just going to be making up a number. I don't know what it really is. It actually depends on the conditions of the experiment. So if you're reacting acetylene with oxygen, okay, sometimes what happens is we don't produce the carbon dioxide in the water. We might produce some other things. Maybe we'll get some carbon monoxide produced as well, or some soot. In other words, this reaction might not go to completion as it is written here. Okay, so we might not get all the products that we want. So we have what's known as a percent yield. So let's just say hypothetically that the percent yield here is 91.5%. Again, it depends on the conditions of the test. Let's say for here it's 91.5%. So I want to know in this particular situation how many grams of carbon dioxide are going to be produced. Well, in order to do that, what we first need to do is figure out which one of these two is going to be the limiting reactant. Okay, we need to know the limiting reactant always to determine the masses of our products. So it doesn't matter which one I pick. I could pick the 50 or the 180. Let's just say we pick the 50 in this particular case of our C2H2, our acetylene gas. So we pick our 50 grams and we figure out, again, how many grams of water, we're going to try to figure out how many grams of oxygen are going to be needed to react with that 50 grams of acetylene. So we convert to moles. And then we do our mole to mole conversion here. So we know for every 2 moles of acetylene, that 5 moles of oxygen will then react with it. And I know that for every 1 mole of oxygen, that it will have a mass of 32.00 grams of oxygen. So now we're in a position where we can do our calculation. And what I get here is 153.6098 ... Okay, and again, significant figures at this point. I'm sure you know how to do them. We got 3 here, we have 4 here, we have infinite here, and 4 here. So I can only keep 3 significant figures, 1, 2, 3. So we have 154 grams of oxygen that are calculated that we would need. Okay, this is what we would need. But how many grams were given? Well, in this case, we have 154 grams is what we need, 180 grams is what we have. So obviously we're going to have an excess amount of oxygen. We can calculate that real quickly. So we have 180 grams is what we are given. 154 grams is what we need to react with our 50 grams of acetylene. So we have 50 grams of acetylene. We won't use all 180. We're only going to use 154 grams of that. So we can then do our calculation here. And with significant figures, I can't use this value here because now we've rounded it off. We don't know what this is. All right. And then so we subtract it out. We get 6 here and 2. So we have 26 grams of oxygen in excess. Okay, and therefore, again, therefore, our C2H2 is going to be limiting. Now, now that we know which one is limiting, we're going to use our limiting reactant to figure out the mass of the CO2 that's going to be produced. So I start with my 50 grams of C2H2 again. I'm going to convert that right away to moles. And we just do our mass to mole to mass calculation like we've been doing all along for stoichiometry. So 26.04 grams of our C2H2, and that's 1 mole of our C2H2. And notice how I'm writing in my labels so things don't get confused or lost. So then we know for every 2 moles of C2H2 that I will produce 4 moles of CO2, and then we know for every 1 mole of CO2, it has a mass of 44.01 grams. And we can do our calculation and figure out the mass will be produced of our CO2. And I calculate 169 grams of CO2. Okay, so that's the mass of CO2 that would be produced in theory. So in theory, 169 grams of CO2 will be produced. But that is assuming then that when this reaction occurs, that these are the products that are all the products that are going to be made. And again, as I mentioned before, sometimes other things might be produced. And there are other reasons why sometimes we don't get 100% of our product. So we're saying here, though, that the percent yield is 91.5%. Now, the percent yield equation looks like this. The percent yield is going to be equal to the actual yield, sometimes referred to as the experimental yield. In other words, if you're conducting an experiment and you measure the amount, that would be the actual yield. And we divide it by the theoretical. The theoretical yield, which I sometimes refer to as the calculated yield. This is the one we can calculate. Okay, and of course times 100. Okay, to give us our percentage. So there's the equation, and we're trying to determine the actual yield here. And so what we're given then is we're given our percent yield of 91.5. We just calculated the theoretical yield of 169, and now we're just solving for the actual yield. So obviously a simple percent calculation, so we have our 91.5 is going to be equal to, and then we'll just say X over our 169 times 100. Okay, and I'm assuming that you know how to solve for a variable like this. Basically, our 91.5, we're going to divide it by 100 and then multiply it by the 169. So X will be equal to 0.915 times our 169. And I get 155. Again, maintaining significant figures, I get 155 grams of CO2. And this would be the actual mass of the CO2 that will be produced when we react 50 grams of acetylene with 180 grams of oxygen with a yield of 91.5%. So just to recap, given the amounts of both reactants here, if you're given the masses of two reactants, then you know you have a limiting reactants type problem. So we have to determine which one of these two is limiting. We did that. We determined the C2H2, or the acetylene, was our limiting reactant. Once we determine which one is limiting, then we can calculate the theoretical mass of the carbon dioxide that will be produced. This is assuming that all the reactants react entirely and the products are as it's written in the equation. And then we use our percent yield to determine then the actual yield. So again, just plugging our numbers into our equation, and that's how we end up getting the 155 grams of CO2. Now, a problem might be a little different, it might read differently. It could be that we're given the experimental amount. Let's say in the experiment, so we're starting a new problem here. Let's say we're given in the experiment that 81.5 grams of CO2 are produced. Okay, and let's also say that in this particular case, 40 grams of C2H2 reacted in excess oxygen. So now we have a situation where you're given the actual amount of carbon dioxide produced in the experiment. Okay, so that's been measured. And we knew that we reacted 40 grams of acetylene and that it's done in excess amount of oxygen, which means that the C2H2 then, in fact, will be our limiting reactant. And the question might read, what is the percent yield? All right, so going back to what the percent yield equation is, we know in this case, we're given the actual yield, okay, but we don't have the theoretical. So we need to calculate the theoretical yield in order to figure out the percent yield here, okay? So let's figure out the theoretical yield from our 40 grams of the reactant. So going back to our 40 grams of C2H2, let's figure out how many grams, in theory, should be produced of the CO2. So 26.04 grams, 1 mole, C2H2. Again, I'm going to put in my labels. I know it takes a little extra work. And then we know for every 2 moles of C2H2, we have 4 moles of CO2. And for every 1 mole of CO2, 44.01 grams. So now let's calculate the theoretical amount of CO2 produced. And I'm going to get here 135 grams of CO2, of carbon dioxide produced. So now this amount is then our theoretical mass. Apologize for the poor handwriting. But anyways, there's our theoretical mass of CO2. So now we can calculate the percent yield. So our percent yield is simply going to be equal to the actual mass that was produced of the CO2, let's say 81.5 grams here, divided by our theoretical, which is 135, and take that all times 100. Okay, so we can calculate that all times 100, and that's going to give us then 60.4%. And there is your percent yield for that type of a problem.